So we're good?
Go for it.
Okay, welcome everybody. Starting a couple of minutes late. Sorry if any of you had trouble getting in. My name's Aaron White, and we're going to be talking about the next generation cloud native API management journey with Layer7. So, some feedback that we've had from some of our customers over the last couple of months is that we we haven't been telling people this enough, right? Of how we are actually a very cloud-friendly solution for API management. So we're going to go through that today. Quick introduction of the team and what the topics will look like. So we're going to look at not only where we've come from and how we've got to where we are, because we've been a cloud-friendly solution for quite a while, but also where we're going. And some of that will be things that maybe you didn't know, and some of it will actually be, kind of hot off the press, what we're doing with our roadmap. Ben, Greg, and myself will be presenting. And actually, the three of us just got back from a week in Richmond, Vancouver, with the development team and some of our partners going through a lot of this stuff. So some of it has been verified, very, very recently last week at that event. And some of the content we'll be talking about will be related to that, and some will be stuff, like I said, we've done. So without further ado, let's kind of find out how we got here, and then I'll hand over to Ben, and then we'll hand over to Gary, and we'll be just getting more and more specific as we go through the speakers. So Layer7's been around a long time. We actually have our first ever developer still works with us, so a guy called Francois Lascelles. And I kind of said, how did this start? And the start was, those three logos in the middle. The focus was around Java, Linux, and XML, and trying to provide all these things at the bottom, right? The number one priority was and has always remained security. But security orchestration, API orchestration, authorization. We built into OTK or OAuth and OpenID flows. They weren't there at the beginning, but the solution has a very flexible and future-proof way of helping us meet new requirements that come in the API space. Technically, 20 years ago, we probably didn't talk about APIs. We talked about web services, B2B services, that kind of stuff. So this is where we started, and as part of that journey, we had XML-based, database-based configuration that we had to manage, deploy, and migrate. And over time, we moved to make that easier by having out-of-the-box solutions. So, the start of it was a standalone Java application, but we migrated into a software installation version and hardware and virtual appliances just to make it easier for people to manage. But some of those things at the bottom remain the same, right? If you've got hardware appliances, you need some in the production environment, some in non-production. So we started to build on the base configuration and build tools. So we had something called WSMan, Web Services Management. And as that evolved, we provided a REST API and other tools that built on top of those to help with migration and configuration management. A lot of those things were more traditional and more static at that time, and things like fully automating and that kind of stuff that we take for granted today wasn't there. We built on those tools. Like I said, we built things like a solution called CMT, and which became GMU, Gateway Migration Utility, and that became more important as the footprint or the possible options for customers to deploy became wider. So hardware, software, and virtual became an AWS image, an Azure image, and then containers. And actually, our container image has been around a long time. And I've put the Docker logo up there. You'll see that changes in a bit. Very, very much at the start of our journey, Docker was the key, right? Docker support, we now running the Docker container was the key. That's probably evolved over time. But that configure, deploy, migrate solution, topic became broader. Customers were running hardware appliances for some solutions and virtual appliances for others, and starting to look at containers. And that journey has evolved, and we'll definitely dive in on that. The key part here, though, is the stuff in the middle. What the gateway does has never really, changed it's changed. It's never changed dependent on the platform you're on. So if you're a security and orchestration use case, or you're a governance use case, or integration is the key for you, whether that's on software, hardware, virtual appliances, moving to containers, we've made sure that we're platform agnostic, and that's really important to us, that customers can change and swap between those things as they want to. We've seen less customers on hardware over the years, more on virtual appliances, and now we're seeing more in containers. And that's really where we are today. And what we're trying to do and focus on right now in our engineering and enablement efforts is that cloud native journey. Now, I've kind of tongue-in-cheek changed the logo from Docker to Kubernetes because that battle seems to be won, right? Whether I'm deploying private Kubernetes cloud, or whether I'm deploying to AKS, EKS, Google's platform, Kubernetes seems to have won that battle, and it's there. And whether I'm using things on top of that, like OpenShift and Tanzu and those sorts of things are still, container based, but that's changed. So we have no plans on kind of stopping everything. We still want to be able to provide software and virtual appliances to be able to run. We still want to provide security orchestration and all those good things in the middle, but we're focusing on making that cloud native deployment easier for our customers and easier for them as they move between environments. So at the bottom, you'll see things are starting to change. We're starting to move away from XML based configuration. Doesn't feel light and the right way to go away. We want to make sure that automation and things like treating configuration as code are valid. So that's where we are. That's what we're trying to do. Our product priorities haven't changed. We've just got a layer on top of how we want to look at that. So all the things around user experience and modernization, things like adding GraphQL and gRPC and all those kinds of things, they're still valid. On top of everything we do, we look at security, and now on top of that, we're looking at how that looks in a cloud deployment. Right? Is it easy enough to do? What are we trying to get to, etc. So our product priorities have stayed pretty static, other than we have this layer now where we know our customers are starting to move to cloud. They're starting to look at containers. They're starting to look at these options they have, and we want to make it as easy as possible for them. So last slide from me, I'll just talk about, our vision. We want to have all our products cloud deployable, and we have some leveling off to do there. The gateway's been around for a long time as a container, so that's good, but we know we need to change that a little bit, make it easier to use. How do we bring in the OWL's toolkit with that? That's a particularly important one for a lot of our customers. The portal, well, the portal is a SaaS offering from us already, but it's also deployed in containers already as Helm charts, etc. But we do want to make sure that we bring those all together. We have a strategy that looks the same, makes it easy for you to deploy, right? You don't want to be learning Helm charts for one type of deployment, another tool for other deployments. We want to get that strategy consistent. We also want to ensure that we do not force our customers to go all the way to the right-hand end of this diagram at the bottom, right? Not all of our customers are ready for cloud native. They're not all ready for everything being fully automated and configured in that way. So we need to make sure that we still support virtual appliances and support data places that may be in the cloud. The cloud means hundreds and thousands of different things to different people, and we want to make sure that we don't just go all out. And there's a couple of reasons for that. Some of our customers have told us they have no desire to move away from virtual appliances, for example, or a software install. But other issues are out there still, like a skill shortage, right? There are not the people that we need in the industry around cloud deployments and containers and managing Kubernetes. Lots of our customers tell us they want to get there, but they don't have the skill set. They don't have the infrastructure in their teams. And some of those projects are taking a lot longer than people thought they would because of that. So we need to keep this broad spectrum of customers in mind as we go through this. That includes things like public and private cloud, support for different regions and zones and clouds, and maybe you want to run your deployment across 2 different providers, let alone 2 different regions or zones. So all those things we're trying to take into account, so we don't give our customers less options. We want to give them more options and make all those things as easy as we can. So that skill shortage, that's something we can help with, right? We can have a product that is easier to deploy, where there are really solid examples. We can't teach everybody Kubernetes, but we can help them once they know enough to get going. We won't stop focusing on security. That's the #1 thing for us, and it drives everything we do. We will have to bring in external solutions. In the past, the biggest requirement that we asked of anybody, depending on how they deployed, was we need a database. In a hardware or virtual appliance, all that was self-contained. But when you move into the more cloud-native deployments, there are things that have to be supplied by the infrastructure. And to do that, we need to enable our customers and partners, etc., to know what external solutions are needed. Right? We need to pick ones that are well known and standard across the industry. Free, if possible, right? Maybe there's some paid options. Optional as well. But many of these we want to make optional as we can, and as open as we can, right? So if you don't like Kibana and you want to use something else, or you want to do your logging to Splunk or something like that, we need to support those things while still providing a first route to go down if you're new to this environment, or you don't know what to choose. So as we look at external solutions, and you'll see a couple of those through the presentation, that will become clear. We want to emphasize user experience. That kind of touches in that skill set conversation I was talking about. This should be easy, as easy as it can be, right? And if you're brand new to Kubernetes, the world isn't easy. But we need to make it as easy as possible, and then make day 2 activities like migration and policy management, configuration as code, all fit into that, so that the journey is easy as well. And we need to support the non-cloud deployments, right? I have customers that install the gateway on things that move around, right? So things with wheels. They're not going to install a full private cloud in those sorts of environments. They want a software deployment for that flexibility. We have customers that have standards that don't include Kubernetes and containers at the moment, so we need to support those as well. So that broad spectrum of journey that our customers are going through, that they need to be able to support. They need to be able to get to cloud and take the advantages of cloud if they're ready, but they also need to just get to cloud in the easiest, simplest way, if that's where where their skill set is and what they've been demanded by their IT departments at the moment. So that's our vision. I'll hand over to Ben. Ben, I'll drive the slides. Just give me a nod when you're ready. Ben will talk about some of the more detailed stuff around this.
Okay, perfect. Thank you for that, Aaron. So Aaron just presented our vision, and I'm going to start by presenting a couple different reference architectures that support that vision. So as Aaron already said, we recognize a broad range of customer cloud maturities. We and many of our customers are leaning into cloud native deployments of Layer7, but we still have customers that need to deploy Layer7 in a more traditional way, but to the cloud. So this is a reference architecture that focuses on our more aggressive cloud native deployment. And when we talk about that, you could characterize it by deploying container gateways, running in Kubernetes with Helm charts, or we're going to introduce a Layer7 operator soon. It's already available as experimental, but we're advancing it to preview this year as an alternative to deployment model that can do everything that Helm can do, but more. Ideally, without a database, driven by configuration as code, from different sources of truth to include, Git repositories, to the portal, to other sources that we're considering, while off-boxing adjacent concerns to external solutions that, customers have long wanted to off-box from our gateways anyway, and have been doing that in a variety of ways to off-box those concerns to a variety of tools. What we're trying to do now is identify and adopt industry standards at our product boundaries to make it easier to just plug us into their existing environments and connect to those external solutions that they would prefer to use for those things. So what are those things they would like us to integrate with instead of provide out of the box? One of those is logging, auditing, tracing, metrics for monitoring, alerting, and analytics. And so that's a pretty broad category in itself. What we're adopting there is open telemetry for logging, tracing, and metrics to be able to push all of that to solutions like Prometheus or Grafana or the X-Stack, which would be Elastic on containers with Kibana, in Kubernetes. Other things that they want to off-box are, OAuth authorization. So using ROTK or any industry standard OAuth solution. And so some of the things we're doing is decoupling the gateway and the portal from ROTK and giving you new, quicker, easier, better ways to deploy the OTK as a service for the portal and or gateway, but also at the same time being able to more directly support other OAuth authorization servers that you might also have. External state management, if you will, for key value storage, but also as a solution for distributing shared rate limits, throughput quotas, and a number of other things that we have supported embedded or external Hazelcast for, if you consider our tactical remote-cast assertion, a variety of other external providers too. So that's another area we're looking in, as well as external secret management. And from a gateway perspective, that could apply to stored passwords or private keys. And Gary will talk a little bit more about that later. So again, this is a cloud native reference architecture. Aaron, if you'll go to the next slide, you'll remember that we want to recognize and support a broad range of cloud maturities. And so we've long had customers in the cloud. Some of them have even been deploying our containers to Kubernetes, but many of them have had a more traditional deployment model in the cloud. So what does that mean? That means they might have deployed any one of our gateway form factors, from virtual appliances running in VMware Cloud in a public or private cloud, to software gateways running on a compute instance in the cloud, to container gateways, running in Kubernetes or otherwise, but probably backed by a shared MySQL database. Now, in the cloud, that might be a managed MySQL database service, but also probably with a more traditional configuration lifecycle across environments. And yet still wanting to, needing to, and being able to off-box a bunch of those same adjacent concerns. So one reason I like to have these two reference architectures side by side is there's as many or more similarities than differences, right? So even though we're aggressively leading into cloud native, as are many of our customers, as we built out the roadmap to do that better, we tried to identify capabilities and design and develop them in such a way that they could benefit more of our customers across those cloud maturities and all the way back to on-prem, in fact, right? We haven't forgotten our on-prem customers. We're always going to have some on-prem customers that are not ready, may never be ready to move to the cloud. And a lot of the things we're working on in this cloud initiative are going to benefit them too. Aaron, if you would go to the next slide, please. So another thing, well, actually, coming off those reference architectures, Aaron touched on this a little bit, but we also came up with some guiding principles for those reference architectures and our roadmap very early on. And these are those, beginning with wanting to have a complete solution that can be easily deployed at scale. So we don't want to just only focus on our products, much less our point products, and help customers just deploy them, but only providing maybe half the solution that they want or need. We want to make sure that we're focused on that complete solution for them, even if it means, leveraging external solutions for adjacent concerns. So that also means identifying our product boundaries. So where do our product capabilities stop? Where do industry standards start to be able to integrate with external solutions outside of our products? And also regional boundaries. As we move to the cloud, many of our customers have a multi-cloud strategy. They want to know that we can they can deploy us across all of the clouds they care about, and that certain of our capabilities will span those clouds. Probably the foremost of those, and the one that immediately comes to mind, are distributed throughput quotas, where we're sharing a throughput counter across, availability zones, regions, clouds, even, hybrid clouds, from public to private clouds, right? So we really wanted to identify product and regional boundaries. Again, we wanted to emphasize adoption of industry standards at those boundaries, so that customers can more easily plug us into their existing environments that already support those standards, so that we will already work with their existing solutions. Now, we're going to show you a lot of cool stuff that we've been working on that do leverage industry standards at those boundaries to integrate with external solutions. And frankly, a lot of our customers might say, wow, we really like that, and we want you to give us all of that, because we don't have existing external solutions that we can connect you to in our environment. Or you know what? Maybe our enterprise or our organization has those things, but our team doesn't own them, and it's really difficult to work with that other team. And really, we just need a solution for us. So if we can deploy that solution together with your products, we'll take that, right? And so what we want to do is, more than maybe ever before, go beyond our product boundaries to a certain extent, to make it easier to deploy at least one ideal external solution that supports those industry standards at each one of those boundaries for each one of those adjacent concerns that we've talked about. So that we have something that we can design, develop, and test against, but also our deployment artifacts can make it easy to actually deploy those external solutions with our products. So if you just want to use them, you could. And so we have additional guiding principles for how to select those external solutions. And Aaron already went through some of them, but bottom line is we want to make sure that they support the same industry standards that we do. They're free, widely adopted, open source, so that customers can use something that's free and reliable, and there's an open source community out there to help support them in that use. At the same time, we would like that there are enterprise license and support options for those free, widely adopted open source solutions, because some of our customers are going to require that if they're going to deploy and use those solutions in a production environment, right? Though we don't want to require that. So we're going to try to avoid capabilities that only come with licensed solutions, so that we're not introducing capabilities that require our customers to pay somebody else to be able to take advantage of them. On top of that, it would be ideal if some of the public cloud providers also offer managed services for those same solutions, because then you get, a lot of additional qualities of service managed by those cloud providers for you on a subscription, and that's a desirable model for many of our customers. Again, we're responsible for our product, but we do want to make it easy for you to deploy these, ideal external solutions that we've selected in our reference architecture based on these guiding principles, and hopefully with broadly applicable defaults that'll maybe work for 80% of our small or medium-sized customers, most of the time, but that could be configurable by you to tweak them to meet maybe your unique requirements. And then as we do that, those are the external solutions that we're gonna, design, develop, and test against, document, in a more limited way, probably mostly pointing to that external solutions documentation to guide your deployment configuration and administration of those based on that solution's best practices. And then we'll be in a position to provide some support, right? We don't support that external solution, but our organization from product to engineering to support is going to have some familiarity with it, right? And though we'll try to trace problems back to our products, which we do support, at least we're going to be somewhat aware of the products you might be using our products together with. And again, at the end of the day, even if we select a preferred solution, to the best of our ability, we want you to be able to plug us in your environments and work with anything you already have based on those industry standards without requiring you to adopt a particular external solution. We might not always be able to do that. Some external solutions we're finding are uniquely capable of doing things our customers want us to do. And so we're dependent on those very specific external solutions. But that's our goal. Aaron, next slide, please. So we also very early on came up with a more detailed phased roadmap to enhance our products in various ways to, execute on that reference architecture to achieve that vision. And this is it. It begins with an emphasis on the gateway in phase one, because the gateway is, still a very foundational product when you consider the gateway, OTK, and portal together, right? And there's a lot of gateway only customers. Not every customer has, also has the OTK or the portal. And it made a lot of sense for us to focus on the gateway and then align the OTK and the portal to that next. So phase one started with the gateway. Phase two adds the portal and OTK. And then phase three was sort of more nice to haves that we think we'll want to have eventually, but we didn't need to have right away. Aaron, if you'll go to the next slide, you'll see that already, probably less than 1 year later, we've actually delivered on many of these things in some capacity. Now, we didn't plan to present the progressive delivery model in this presentation. Hopefully more of you are becoming familiar with it through, other office hours or webinars that it's been presented in. But we've adopted a progressive delivery model to let us deliver new functionality to our customers faster, to get it in your hands earlier so that you can start providing feedback and indicating demand sooner to further influence those features such that we can then prioritize them and accelerate them from experimental to preview to GA. So when you look at this color-coded representation of where we are today, green is available in some progressive delivery states. So some of those things might still only be experimental. We've actually advanced many of them to, preview. Once a feature's in preview, for the most part, we're able to offer limited availability support in production environments to a handful of customers. So, many of these capabilities are already or will soon be available for some customers to use in production if you're an early adopter and want to do that soon. Other things we've started, other things we have yet to start. You'll notice that we actually already pulled some things forward from phase three. That's because some of the early work we did, some of the feedback that we got, showed a strong interest in some of those things that we actually began by thinking we would do later. We realize now that either they're well aligned with things we're working on early, or customers are very interested in having those things sooner. So Aaron, if you can go to the next slide, please. We got just 2 more slides, and then I'll hand it off to Gary that talk at even a lower level for what we're working on in our next PI or program increment, which is sort of our largest unit of work in our agile process here at Broadcom, which is made up of 7 2-week sprints where things get done, right? And these are the gateway features that we identified for PI 35, which will start in a couple weeks. And there's many things we work on for many different reasons. What I did here is I highlighted the features that are related to the cloud initiative, right? So actually going into PI 35, we sort of described this PI as, focused on some blocking and tackling for JDK and Debian upgrades for our next major gateway release, 11.1, due at the end of March of 2024. subject to change, of course, and slowing down on some of our, progressive delivery features for the cloud initiative, because we've already delivered so many of those things that way. And now we're waiting to see customers ask for it, use it, provide feedback, indicate demand, right? But even saying that, you can see that we still have quite a few things that are directly or indirectly related to that cloud initiative in this PI. Aaron, if you'll go to the next slide, please. That's also true for the gateway. Now, Portal. Now, Portal, as you saw from that phased roadmap, was really going to start picking up in phase 2. Portal's already done some cloud deployment initiative related work in previous PIs. It's starting to pick that up a little bit more. These are some of the features in the Portal's next PI that are directly or indirectly related to the cloud initiative. And we would expect to see that ramp up even more for the Portal going forward. So an even more detailed look of what we're going to begin working on next, if you will. So that's all I had. Why don't we roll over to Gary now? I think you wanted to give Gary control. So
yeah, Gary, do you want to share your screen? Just while Gary's doing that, if there are any questions that people have, I know how it works, right? It's a group, you don't know who's on there. If you want to put a question in the chat, you can use the chat in the WebEx just fine, and Ben and I can maybe answer things in the background while Gary's talking, or we'll save him till the end, but feel free to use the chat if you've got any questions. Thanks. Over to you, Gary.
Thanks, Aaron. Thanks, Ben. So today I'm going to introduce a very high-level overview of our Layer 7 Kubernetes operator. I'll also touch on next-level observability with OpenTelemetry, and I'll also give you some insight into what we're doing with external secret management. So for this, I do have a couple of demos. They're going to be I guess examples. They're going to be very, very high level. So you don't need to have any Kubernetes experience or even sort of any gateway experience to sort of see what we're doing with that. Obviously, we can go into a lot more detail on those. So as Aaron mentioned, if there's questions, please feel free to add those to the chat. And if you'd like to have a follow-up call, then please reach out to us for that as well. So Kubernetes is great at managing applications and deployments in general. What it doesn't have, though, is any domain-specific knowledge about our Layer 7 API gateway or other applications and services. So things are fairly generic from an application perspective in Kubernetes. And that leaves complex tasks to manual intervention or custom scripts and or workflows. And those can be difficult to build, document, share, maintain, and support from short-term, medium-term, and long-term perspectives. So that's where operators come in. So operators are software extensions to Kubernetes. They make use of custom resources. We'll introduce those in a little bit. And those custom resources manage applications and those and the components. Operators follow standard Kubernetes principles. Most notably is the control loop, which I have just a very simple diagram on the right of. So the first step is observe. So has something changed? That pertains to a custom resource that we manage. In the context of gateway, that'll be a gateway custom resource or a repository custom resource currently. In the future, that'll also pertain to Portal and APIs. There's then an analyze step. So do I need to do anything? And what we're looking at here is does the desired state of my new configuration match what's currently available in my Kubernetes cluster or on my gateway deployment? So does desired state match reality? And then finally, if desired state doesn't match reality, then act by doing something in Kubernetes, doing something to a deployment to get desired state to reality. So very, very simple. Very, very simple reconcile loop or control loop that we follow for that. And what that enables us to do is add additional functionality to Kubernetes without changing or maintaining the core code of Kubernetes. So that also allows us to take deep domain-specific knowledge that Kubernetes doesn't have and write code to automate tasks beyond what Kubernetes can do natively. So extending Kubernetes to also be able to manage Layer 7 gateways or other applications that we support. So the Layer7 gateway, so the Layer7 gateway operator was built using the operator SDK. The operator SDK is the most popular framework for building operators, building Kubernetes operators. At the moment, the Layer7 operator controls two custom resources. There's Gateway, which covers all aspects of instantiating one or more API gateway deployments into Kubernetes, and repositories. And that enables Git integration. So Git integration of operator to an external Git repository, and that provides static and dynamic configuration synchronization at scale. There are also additional custom resources that we're looking at for, as Aaron and Ben mentioned, we're looking at extending this to Portal as well. Additional custom resources to facilitate an integration with Portal, as well as APIs, whether they're Portal managed or gateway managed, for storing those in Git and applying them differently. So all of this redefines the way that customers can use and operate our container gateway in Kubernetes going forward. So going into the configuration lifecycle model, so this was touched on in the sort of previous architecture diagram. This goes into that in a bit more detail. So what we've done is broken down configuration as code into 3 distinct categories, and this mirrors what some of our largest customers are doing in their environments today with Gateway. So we've got the common framework. So we've got the common framework config that represents things that aren't going to change very often. So things that underpin all or most gateway deployments. There's API specific config, which relates to APIs and services that are on your gateway. And then there's common business configuration, which relates to things that you don't necessarily need to have Layer7 expertise to use and update. All of these have different security stakeholders. So the framework is going to have an API framework organization, API publishers for API specific config, and business users should be able to use the common business config. And whether that's directly in something like Git, or if it's an interface that's built for this, so either of those use cases should be fine. All 3 of these represent Git repositories. So that could be GitHub, that could be GitLab, Bitbucket, etc. And from an operator perspective, the operator is going to be configured to monitor those repositories and apply those and apply any changes that get made at runtime or statically by requiring a redeployment of gateways. So this is not the only way to use config as code. This is just an example of how to separate the different parts of the gateway. So one of the other things that's sort of worth mentioning in this is the Layer7 gateway in ephemeral mode. Ben mentioned that earlier as being the sort of preferred model for this, and that means in this mode you don't have any database dependencies, so you can run this easy, more easily across different zones and regions without that database dependency, and with your source of truth being this configuration. So I'm going to show a very, very quick demo of updating these repositories. We're going to stay in a browser for this. Very, very simply, I've got a service on my gateway, so just v1 config. That's going to return a demo config value, and if I refresh that, that's just my config val. If I head over to the repository that I'm referencing that contains this, I can see the repository structure here. So this has a tree for APIs. It also has cluster properties. Each gateway entity has its own folder. So cluster properties has its own folder. If I had something like scheduled tasks or keys or certs, they would all receive their own. Folders. This is just a very, very simple sort of breakdown of that. So in this config as code, I've got a very simple API in here, and I've also got a cluster property, which is demo config val.json. And all we're going to do here is change this to my new config val. And what's going to happen when I update that is the Layer7 operator is going to reconcile that with my API gateway, And when I refresh the page, and when I refresh that API call in the previous tab, which I'll do shortly, then I should see the new value there. So the other thing to note here is currently we're using a branch. The other thing that supports it is going to be using tags. So if you have, so if you don't want changes to a particular branch to trigger an update to your gateway, then you can equally just use a tag, which is going to be immutable and always have the same configuration applied to any gateways that you bring up or any gateways that come up. So if I come back to this, tab and refresh, then I can see I've got my new config val there. So very, very simple, very simple demonstration of how to use repositories and how the configuration is applied in the background. So the next thing is going to be secrets management. So something that's come in probably the last sort of 5-10 years, but certainly the last sort of 2 to 3 years with the sort of rising and working from home is centralized secret and key management. So centralized KMSs have become a lot more utilized, so a lot more abundant in the providers that have them, as well as a lot more utilized from organizations across various industries. Centralized key secret management solutions have enterprise-wide implications on how credentials are used, managed, and accessed across all applications. So there's some assumptions that we make with this, and some things that we think are important to support. So because secret and key rotation has become more frequent and in a lot of cases automated and recommended by central key management solutions, that's something that we want to, as a day two activity, remove. So we want that process to be simple for our gateway customers to sort of take advantage of that rotation without incurring any downtime when those updates take place, and also making sure that when a change happens in one place, it's propagated everywhere. So there's an expectation that you don't have to manage something in 2 places. So there's going to be two options for this. The first is going to be a policy-based framework. This is something that's going to work across all form factors. This is going to work with a synchronization on demand or via a background task. This would rely on a direct integration with a key management solution. Ideally, from a security standpoint, this is probably the best solution that you can go with, having a direct level integration with the KMS, so that you don't have that secret sort of existing anywhere else except in runtime or on the KMS. And what we'll be providing is a policy-based framework for you to integrate with your external KMS, and as well as some examples to help you along with that. So the other approach is taking advantage. So the other approach is going to be limited to the container gateway in Kubernetes that's managed by the Layer7 operator. So there's also something called the external secrets operator. The external secrets operator exists as a medium to a variety of different KMS solutions. And what that does is takes a set of secrets that you specify in configuration, and it synchronizes them down into a set of Kubernetes secrets. The Layer7 operator is simply configured to take a look at those Kubernetes secrets. So they can be configured by the external secrets operator. They can also be configured by Kubernetes admins that you have, or by local admins in a namespace. And you can then apply those directly to an API gateway and have them updated in real time. So the operator is going to keep them up to date with whatever the current value is. So in that, the external secrets operator manages that KMS integration. And the one downside is going to be that Kubernetes secret is going to exist in the Kubernetes environment. We do have a couple of mitigations for that. So keeping secrets encrypted at rest. With Grafman, which is our management tool, being able to understand that. And those are things that we can discuss in sort of more detail in the future. So the next really exciting thing from an API from our cloud native architecture is going to be observability. So for this, we've gone with an integration with OpenTelemetry, as Ben mentioned. So OpenTelemetry is an observability framework and toolkit. designed to create, manage, create and manage telemetry data that includes traces, metrics, and logs. One of the main reasons that we've chosen this is because it's vendor and tool agnostic. That means from a gateway perspective, we build and maintain one integration with the OpenTelemetry SDK that can work across multiple observability backends. So I think at the moment, there's around 20 plus different observability backends that support OpenTelemetry, and that allows us to really focus on getting value out of the gateway, getting value out of the gateway, and then allowing you to observe that in whichever backend, observability backend that you currently have in place. So you won't need to change to a specific backend to get some of the metrics that I'll be showing you today. It's also extensible. There's bounded resources, so OpenTelemetry has ways to make sure that you're not utilizing all of the network bandwidth. So there's rollup jobs and batch that happens there's rollup jobs and batch that happens directly in the OpenTelemetry collector side of things. And OpenTelemetry is a result of two CNCF projects, or Cloud Native Cloud Computing Foundation projects, called OpenTracing and OpenCensus. So this is a few years in the making, and the end result is OpenTelemetry. So we have automatic and manual instrumentation. So what I'm going to show you, shortly, is a dashboard that we've created for Elastic. The dashboard that we've created for Kibana. Kibana is part of the Elastic Stack. We've chosen the Elastic Stack in our reference architecture because it includes logs, metrics, and traces. So it includes tools for that, tools for all of those, and there are several open source components. So you can get started with the Elastic Stack without necessarily requiring a commercial license. The dashboard that I'm showing you is not the only one that you can create. You can use any telemetry backend of your or observability backend of your choosing. So the next thing that I'll also show, so I'll kind of go into showing that as well, is tracing. So the first dashboard that you'll see will give us a very brief overview of some of the stuff that's available on our gateways. Or some of the stuff that's happening on our gateways. Tracing takes it to the next level, and it gives us a much deeper view of exactly which assertions are being used, what's happening in a policy, where a policy is failing, if it's failing, and it allows us to capture a whole lot more information on demand. So another key thing with this integration is that, or with the tracing integration, is that it can be enabled on demand without restarting the gateway. So if you had something like a problem in one of your environments and you wanted to take a look at, you had a service or an API that was failing, you wanted to take a sort of more in-depth look at it, you could enable that cluster-wide property for that service, and you could take a look at it in sort of near real time and find out exactly what's going wrong in that. So the dashboard for Elastic, let's quickly go to that, and we've got a few minutes left. So this example is available in our operator repository. So if you would like access to that, then you can reach out to us and we can give you access to that from an experimental standpoint. I'll go into the Layer7 gateway dashboard first. And this is the default dashboard that we get with the Layer7 with the Layer7 operator and the OpenTelemetry integration. I'm just going to update that for the last 6 hours so we get some more metrics. So we've got some basic service information that's coming through here. We also have CPU and system utilization, as well as some general metrics coming back from our gateway deployment. We can serve multiple gateway deployments from this. So I've got SSG there. If I had more gateway deployments, I could filter on the basis of those as well. This is an ephemeral gateway. I don't have any database connections, and so there's no database connections there. If I wanted to extend this, so let's say for example that I wanted to also capture some additional metrics about which clients, which clients and which agencies are using my gateway, which applications. That's fairly simple too. So I've got another example here with my gateway dashboard. We're looking at a couple of headers coming in from requests, and we can see here I've got some additional metrics coming in through here. So you could customize this if you use Elasticsearch. You could add your own dashboard similar to this for metrics that you're capturing, for metrics that are important to you, whether you're using AppDynamics, Dynatrace, Elastic, etc. There's a variety of backends that support OpenTelemetry. So the other thing that's really important, as mentioned, is the tracing side of things. So what's actually happening from a tracing perspective? And I've got fairly open tracing defined here, so we should be capturing a fair amount of this. For that, I'm going to go to APM. And here I can see a bunch of services that are being called. I've run some background tasks. I'm going to search for transaction 3. So I can search for transactions by their name. These correspond to the name of APIs that I have on this gateway. So I'll go for test 3, and I'll update that. So I've now got a filter for test 3. I can get some basic information about latency, throughput, and I can also take a look at some of the trace samples that are coming back through here. And this API has a failure. And I can see exactly in policy through this breakdown of what's happening. So I've got a breakdown of all of the different assertions that are being used. So this corresponds directly back to policy level assertions that I have in my API gateway policy, and I can see exactly where that's failing and what's happening thereafter. I can also correlate that with logs. So if I go to the logs here, this can be tuned up and tuned down as per requirement. And I've got the a log correlating the request message here. I can see the agency, the client ID, as well as some information about the originating request that I can use to then sort of take a look and resolve that if that's related to one of those things. And obviously that's this is information that you can tune down, tune up based on the level of verbosity that you want in this. So with that, I've given you just a quick intro into some of the OpenTelemetry, integration, some of the metrics and some of the data that we're getting back. So the other thing with OpenTelemetry or the configuration is so parallel configuration for the OpenTelemetry collector. So Jaeger is another really popular open source tracing tool. So you can also use that. This environment is going back to that as well. So if I go for test 4 for the last 3 hours, I can also see a similar trace on that. So very extensible, very customizable, and very powerful from an observability standpoint.
Hey, thanks, Gary. And you've literally left us 2 minutes to wrap up, which I think is about perfect. So yeah, I think hopefully you've seen where we're going, right? If you're in that journey already and you're starting to look at those things, maybe a lot of things made sense, and there were a couple of offers out there. If you want to get hold of this, let us know, and I would extend that to everything you've seen. If you want to start to touch some of the stuff Ben and Gary showed, then we are open for that for sure. Please contact us or your standard Broadcom connections that you have, and they'll come to us and we can work together on those. If some of that you didn't understand, that offer is exactly the same. We'd love to have a little bit more of an in-depth conversation and allow you to, maybe draw your environment up and we can map what we're doing to that. If it was just, really early for you and there's some stuff you don't understand, what an operator is, for instance, and how that fits into Kubernetes. Maybe you're just starting to look at your cloud strategy and how you're going to move to containers. Again, we'd love to have those conversations. As Ben said, we've done a lot of work. We think we've got it right. We think we've got the right strategy. But we want to validate that with as many people as possible, with as many different viewpoints as possible, very early in their journey to, maybe much more mature in their journey. So with a minute left, there are no questions in chat, but if anybody's got any, they want to come off mute and shout out at me, that would be great. We will share the recording and just give people a chance if they want to come off mute.
Yeah, I have a small question about the telemetry integration. How do you deploy that if you are using API gateways in pods within Kubernetes? So how does the telemetry information will be sent to Elastic or whatever if you scale up and a new pod is raised and its functionality? Is that in the script or is that in the config of the API gateway the moment you spin it up within Kubernetes? How do you see that? How does that work from your opinion?
So currently there's the OpenTelemetry operator that runs in Kubernetes, and we have documentation on how to deploy that. We use a sidecar configuration for the API gateway. So each gateway pod has an OTC an OpenTelemetry container collector in it.
Okay.
That's how we make sure that each gateway is reporting in. There are also other configurations that are possible as well with OpenTelemetry, but that is the easiest way to make sure that you're getting metrics for a specific pod.
Yeah. Okay.
Yeah, a couple other things to point out there. That's just one way to deploy our container gateway with OpenTelemetry to Kubernetes. These capabilities are meant to be a cross form factor. So we should be able to emit OpenTelemetry logs, traces, metrics with any of our other gateway form factors too. Regardless of how you deployed it with which form factor, then there's configuration on the gateway itself to enable, disable it, and then if enabled, to further filter it on the gateway. So the gateway is only collecting, traces for certain assertions, for certain services coming from, for requests coming from a specific client IP address, right? And that's called head sampling, so that we're not even emitting things that don't pass our filters at all. Then you can also go to the collector and do what's called tail sampling. So we emit a lot, but then in the collector, you further filter it and you control to how many different destinations you might send it, right? So a lot of flexibility in that.
Yeah. Nice. Thanks.
Yep, you bet.
And Jasper, one of your colleagues was with us last week, so I'm sure he'll be able to help you out and explain some of that when he's maybe got over the jet lag of flying back.
Yeah, I've already asked him to share the information and do the presentation for the team. So yeah, well, we're in the middle of it. So we are now starting to implement our first gateway implementation within Kubernetes in our infrastructure. So we're playing with it a lot, and I like the telemetry implementation also. So it gives us more information about how the things are running. If we grew bigger and bigger, because we are really starting small with just one customer, of course.
Okay, I'm aware we've gone over the time. Like I said, that offer is out there. We would love to have plenty of people. Do you any plans to provide Gateway 11 on an AWS marketplace?
Not as an AMI, if that's what you're asking, currently. So as many of you may already know, we deprecated our AMIs in AWS, our VHDs in Azure with the 10.1 gateway release. So that was the last gateway version that would support those. Right now, we don't have any specific plans to bring them back. The idea is that customers can leverage any of our other gateway form factors in those clouds. So either our virtual appliance in VMware Cloud in Azure or AWS, or our software gateway installed to compute instances in both, or our container gateways deployed to EKS or AKS.
Yeah, there's a couple of people dropping. I mean, basically, Ben, we want to be as cloud friendly as possible and agnostic as possible, right? That's definitely what we're trying to do. So, you bring your cloud, we can spin it up and not be too specific. So I've seen people drop off. If there are no other questions, then we will let everybody go. We will. I think we're planning on sharing the recording. Work on that with Bill. And any questions, any follow-up, any desire to start looking at this or just talking it through with us in more detail, please let us know, because we're keen to get that feedback. Thank you very much for your time, everybody.
Thank you, folks. Take care.
Thank you.
Thank you.
Thank you.
Thanks, Gary.